going over your Inbody sheet, there's a lot of data here, which we know is a lot of good data. And it's important. It's important for goal setting and determining a lot of our food amounts and everything as well. So let's go through this together. I'm going to draw a few lines on here. But essentially, let's start with our total weight, right? We're going to use Jane Doe as an example. Jane Doe is 5 foot, what's that say? 1.8 inches. She's 51 years old, and she's a female. Okay, all of that comes into play here. So we start with our total body weight right here. It comes from 3 categories. First is water. We want this to be at least 45% for girls, 50% for guys. But we need to be aiming for closer to 60%. So if we took 60 divided by 130, we know that's a little less than half. So Jane Doe here needs to drink a little bit more water. All right, and we'll explain why later, why that is so important for our goal setting. Another category is pounds of fat, body fat mass, 48.7. And then the third category is the everything else category. We'll call it the scrapple category. That is your bones, organs, all that other stuff there. So those 3 together equal total body weight. So if we come down here, we see this dash in this gray area. So coming straight down here with my pretty lines, this general range here is what the government says is ideal for your age, your height, and your gender, as we demonstrated up here. Because what? Women have more fat than guys, taller people weigh more than shorter people, all that stuff. So now we're comparing apples to apples, and it's a level playing field. So let's look at Jane Doe. This is our muscle fat analysis. Her weight, putting her right at the high end of ideal, which 5'1", 130, yeah, that sounds about right. Okay. And then skeletal muscle mass. These are the muscles we can actually make bigger and stronger. It's telling us that she is just at or below the minimum for ideal. Third column, third row is body fat mass, pounds of fat. It's telling us that Jane Doe is higher than the ideal range. So let's talk about how to adjust all these, because more important than being in the ideal range is having what we call a D curve. And that's if, your chart is shaped like the letter D, it comes out like this. Hopefully you can see that, right? Versus what Jane has here, which is a C curve, where it's more inverted. So there's 3 ways we can fix that. One is Jane could not eat that much, and she could do a ton of cardio, and she could take her weight and her fat back this way dramatically. But as well, her muscle is going to go with it. Okay? Or Jane could eat a ton of food and power lift every day, lift really heavy, and move muscle and weight really far this way. But as well, she's going to have to take some fat with her. Or Jane, this is where I plug CrossFit, can do some weight training and some cardio every day. So what will happen is, she'll do her weight training, which will help probably move this up a little bit. Her muscle will go up a little bit faster, but fat will go down slowly. But then when Jane does a little bit of cardio every day, this will move a little farther, as well as the weight, and muscle will stay the same. Maybe go up a little bit more still. So that's essentially how we get all 3 of these to move at the same time to eventually get a D curve. Okay. As we scroll down, we see BMI. BMI is body mass index, which is total weight divided by how big you are size-wise, right? Total volume of body. What it doesn't take into account is muscle versus fat. So somebody with a lot of muscle will appear to be obese. Like myself, on my chart, I am obese because it's not separating the 2. So we take this with a grain of salt. More importantly is our percent body fat. And again, we have this range of what the government deems as ideal. And Jane here is at 37.5. So Jane needs to get this down. So up here, we talked a little bit about water. So if this is down in the ideal range, which for men is between, I think, 10 and 20%, women is, 18 to 28, we need to get this moving. So one of the easiest ways to do that is increase our water. So you've heard the saying that muscle weighs more than fat. That is because muscle holds more water. Think of it like a balloon. You fill the balloon up, it's going to become more dense and it's going to get bigger. Okay. So if water weight goes up, but body weight doesn't because she's doing a little bit of cardio, dropping to fat, now we're dividing less fat by a higher number of weight. Does that make sense? It is dividing fat by a higher number, which means lower body fat percentage. Okay. So step one, drink more water. For each pound of water you retain, about a third to a half maybe will stay in your body and help with the muscle. So that's the easiest way to lower your body fat percentage. So as we scroll down, we have segmental lean analysis. This is why we separate our arms. It measures your limbs separately. So the top line here is how much your limbs weigh. And what we're looking for is how close are they? Are they in balance? And I look at Jane, she's pretty good, legs are pretty good. And this pounds is everything except fat. Okay. The percentage is similar to what it was up here, where we want to get you closer to the 100th percentile. So Jane here is well below ideal for her arms and extremely below ideal for her legs. So we need to add a little bit of muscle to these limbs. Okay. Down the bottom is a chart. As we do our scans, it is going to fluctuate. Is weight going down? Is it going up? Same with muscle and same with percent body fat. Now, when we talk about this chart here, we want to get each number to the ideal range, which is this 100 percentile, the most ideal, the most average. Jane has 48.7 pounds of fat. Now, she doesn't want to lose 48.7 because she'll be all the way to 0 and she will be a skeleton. So how much does Jane lose to get to the 100? Well, it tells us right up here. This is our lean body fat mass control right here. So it tells us whether we need to lose or gain fat, lose or gain muscle. Okay. So Jane, if she lost 22 pounds of fat, it would take her 48.7, put it right here in the middle. So now Jane has a clear goal. But it's also telling us that Jane needs to gain some muscle because, as we said before, she is on the low end of the ideal range. So she needs to put on 8.4 pounds. Reverting back to the water, easiest way to do that, drink a lot more water. She has plenty of room to go. Okay. So when we set goals now, it becomes fat loss and or muscle gain as opposed to the weight. Sure, weight loss is great, but now we have a backup plan. Okay. Well, how long will this take? Well, for Jane, if she's dialed in on nutrition, 85 to 90% of the time, she could do 1.5 to 2 pounds a week. So 2 pounds a week, that's 11 weeks. If she is kind of doing well with the food, barely exercising, Jane could do about a pound a week of fat. Remember, this is not body weight, this is fat. So she's looking at 22 weeks now, which is roughly almost 6 months kind of thing. So this becomes the goal. Now the goals become black and white, and we can actually measure, are we getting stronger? Are we losing fat? There's no gray area anymore. All right. We have lean body mass. This is kind of like your lean muscle mass, how much muscle is in your body. It basically took the total water and dry lean mass and added them together. This number is going to be important for later when we determine our blocks. Lastly, we have our basal metabolic rate, BMR. This is how many calories your body requires and burns in 24 hours if you are in a coma. So this does not take into account walking to your car, going up and down stairs, working, standing up, all of that. And there are some multipliers for this as well, so we can determine calories. But we're going to focus on this lean body mass next. So this is how to interpret the numbers for your in-body scan. And of course, ask questions as you have.